Good afternoon, everyone. My name is Osman Cisse. I'm the team captain of the Piper Pathfinders, the Hamline Piper Pathfinders. And today, in this technical analysis video, we're going to be talking about the drone build, the whole presentation, the walkthrough of the competition, the challenges and of the fly-off, and we're going to also talk about some of our data and results that we collected.
Hey, how's it going? Kyle Wendorf, in charge of the piloting section of things. I'm a physics major with a emphasis in engineering, applied physics with emphasis engineering. Yeah, get into things today here.
My name's Ted. I did most of the electrical and coding portion, as well as helping with the mechanical design of things.
Hey, I'm Nicholas Krivda. I'm also applied physicist with emphasis engineering with a minor math. And I was a co-pilot with Kyle, and I also worked on the collection mechanism.
Okay, so the first thing we want to talk about is just the drone build process of how everything went from like month since November all the way to like the fly-off day. So throughout the drone build process, we encountered a series of like obstacles that really stifled our creativity and our innovation. But we try to accommodate those obstacles to just achieve the goal that was set, which is collect 1 cubic centimeter of samples, both solid and liquid, and we were able to successfully collect that. My team member Ted will show those samples.
So right here we have just under 1 cubic centimeter of the liquid. It's got slight metallic substances in there. We figured that out by using a magnet that we were given and just holding it up. It attracts some of the particulates that are in there. I can be able to really see it on there. And then for our solid matter, we have some kind of metallic substance, as well as a bunch of just like sedimentary rock type stuff. So if you hold up the magnet, you can see it latched on pretty hard. So
More than a cubic.
yeah, and this was well over a cubic centimeter. It was about 1.4. I don't know if you can see on the top well, but there's a bunch of metallic substance that separates from the traditional rocks from the bottom. So figured out that this is a highly magnetic field that we were working in. So probably electrical signals could get damped somehow. So figured that's our little technical analysis of the environment that we were working in.
So next up, we had to give a presentation. And from that presentation, we got feedbacks from the judges. And although the time crunch was really tough to make any significant adjustments, we took some of the judges' advices into our preparation for the fly-off. And one advice that we took into the fly-off was Ben's advice of saying whether if our collection mechanism doesn't work for the solid, we could use a double-sided sticky tape to get solid, and that was successful because
that's what we ended up using.
That's what we ended up using to get the solid, and we were able to get well over the required amount because during competition day, our server wasn't working properly with the collection mechanism that we had designed, so we had to go with the all simple but yet efficient way of collecting the solid.
Yeah, so its original idea was for it to operate when it activates. It will just do a simple scoop method, and we had it set up on a loop, and what happened was the loop didn't activate properly, so it moved backwards.
And even if it were to operate properly, the level of control over the drone would have been really hard to keep it steady while it swings. So we actually came up with a kind of a last minute fix with just a little scoop on the end of a popsicle stick, and then we attached that, and we were able to dunk it in and grab our liquid sample. So we were able to adapt and overcome for that aspect, which is nice.
And the way that we attached both of those was using sticky Velcro, 3M sticky Velcro. One side is sticky tape and the other side is just Velcro. So we were able to attach that right onto the outside of the legs. So for an easy fix.
pull up the walkthrough video.
All right.
And next up, Nico is gonna talk more about the walkthrough because since he's our co-pilot, Kyle wasn't able to be there, so he and I went through the walkthrough phase of the competition.
All right, like Cisse said, I was directing Cisse with the drone. And during the walkthrough, I was telling Cisse how to hold the drone, to rotate, tilt, and that actually ended up being sort of a challenge throughout the walkthrough, because communicating to a person how you want a drone to function is actually decently difficult. Now, during the walkthrough, we were supposed to be able to collect some raw data. Unfortunately, we didn't have our code ready at the time of the walkthrough. We were really scrambling on time. So we just did the walkthrough to practice to see how we would take courses of action during the actual competition. So we practiced taking routes with the drone, and also the 3 phases we were going to have for the drone during the actual competition. So we practiced attaching, detaching, the TNC, the camera, the collection mechanism, and things like that. And then Cisse acting as the drone flying, going in and out of the field. So that's what this video is showing.
Yeah.
Next up, we're gonna be talking about the challenge competition day and some of the challenges we experienced and some of the makeshift engineering that we had to do to achieve our goal ultimately, which is collecting a cubic centimeter of samples, both liquid and solid, and also getting some sensor data from the environment and some images. So
Yeah, as you can see from the video, yeah, so from the beginning here, this is the start of our challenge. And the first area that we decided, because we're going with our 3-phase plan as outlined in our presentation. So our first phase, I believe, changed it up last second, but we were going to do our data collection with the TNC and sensors. We got them onto the drone via double-sided tape. So we just stuck them on here, and then we used electrical tape to mount the sensors to the side. This was going pretty well, and then we realized after the fact that, as Ted had mentioned earlier, the code wasn't working appropriately. So unfortunately, we have no data to show from our sensor suite. It is what it is. We will move past that. And the second phase, we were going into working with the camera. This was really successful as we were able to design a method for top-down view as well as forward-facing. So we were able to go over the top collection bucket. I don't know if you can skip to that portion. But yeah, we were able to see the top bucket from the overhead view, as well as some of the other.
We have the eye test radio.
Yeah, we were able to see and we were also able to see that hidden image on the back side of that box, as you can see there. So this was pretty successful. So yeah, right here you see we got a view of that.
Yeah, so I'm guessing this is a code. So you have blue, teal, orange, and red as the code. Don't know what it stands for, if that's something special to bring up, but we have that. Also for the, there's technically an eye test on the back.
Mhm.
Our image quality wasn't that great, so we weren't able to get a clear reading on it. The one that we saw just a minute ago. Who was this one? Yeah, so piece of paper. Oh, all over the place. Yeah, so this paper right here is just an eye test. Can't really read it. We do know it says how far down can you read? Pretty much hardly the first line. Mainly due to the camera. I think in the future we'd probably use a different type of camera, especially lighter in weight, so we have more room for other sensors and the like. moving over to the code quick. The main, come on. All right, so the main issue with the code that we ran into, so initially when it was set up, we have the SD card for we have like a Boolean that's called SD active. We set that to true. And then when I first started the loop, if it was false, it would open the SD, which realistically the first iteration, it should already be open. But when it went through, it I don't know if it didn't just collect the log properly or whatnot, but I think it called this wrong, and then it didn't actually close the file, so it didn't save any of the data. There was only one object in there, and it was a blank one since the sensor didn't have any readings on the first tick. So really not much to go off the code here. I was in the process of getting both sensors set up. I ran into issues with the LSM sensor, but I got that to work. And then the barometric sensor, so getting the height, we weren't able to get I wasn't able to get that one to work since we accidentally ordered a quick sensor, which kind of throws off the traditional wiring guide, which it should have worked, but I guess that's one issue that's can be avoided in the future is just getting a non-quick device for that. And then also running into the next thing.
So, like throughout the competition, we experience challenges, just like in every single engineering excavation, you experience challenges. But I'm proud of our team because whenever an issue arises, we were able to like resolve it quickly. And our pilot Cal was successful at piloting and achieving the task that was set at end with him. And when the collection mechanism wasn't working, we like the physicists we thought quickly and we used double-sided sticky tape that we had initially brought in and planned for as a backup plan in case everything went away during competition time, and we did that and we got the samples correct successfully. So during the competition time, there were like some things that went bad in terms of the sensors wasn't working, our camera didn't have the amount of pixel to display good images. But however, coming towards the ending of it, we were able to achieve the main task, which is collecting a cubic centimeter of samples, both liquid and solid. And I would consider that a successful flight run. And if we had more time and more and less restrictions in terms of how we can modify the drone, we'll be able to achieve all in regards to the sensor data, well clear image, and also getting the altitude of things. Now, Ted will talk more about our 3D mapping software that we were going to use.
Yeah, so as I mentioned in the oral presentation a couple weeks ago, we were going to use the program Regard 3D, and I ran into a small issue with that. So basically what we did is we took snapshots of the video that we recorded from the drone's first-person view camera, and I tried to use those images to create the mapping of the 3D area, creating the 3D model. The main issue with it was that the camera itself didn't have any, it didn't have I guess, initialized focal length in like a spreadsheet or whatnot. So I wasn't able to use a camera off a spreadsheet to know with the known focal length to actually use linearization for the, I guess, data point triangulation. And I was able to put it in manually as 30 millimeters, but even then the program didn't want to save it and use it. So we weren't able to actually get any data out of the pictures that we got from the video footage. So sadly, we don't have any 3D modeling to actually provide of the environment that we flew around. So yeah, that's about it.
I would say like one thing to note for some of these failures that we had. I mean, I definitely have learned that you know we had all these plans and these good ideas and stuff like that. And like we tested the Regard 3D and it's worked before, but we never really, as a group, had done enough testing with our drone, like actually done. Like, you know what I mean? Like we hadn't taken a video and then tried to break it down and process it into the regard. We hadn't tried to do a collection and like that. So I think in the future, the smartest thing would be to have the drone ready, like try to have it ready like a couple weeks in advance, which we did try to do. We did try to do in all honesty, but you know, when push comes to shove, there's other priorities and stuff like that and schedules. And, you know, it's one big project. So granted, we didn't complete all aspects. I would still consider this a success because I know I learned a lot and I'm assuming everyone else here has. So
Yeah, coming into this competition last year and this year, I've actually learned a lot in terms of electronics and also like coding sensors. And I feel like those are skills that I will take into my future career path based on this, and also the amount of like camaraderie and like communication and teamwork aspect of things. I've actually learned a lot. Okay.
Yeah, I learned a lot more about CAD. Also, one of the issues I had along the way is my computer stopped working, and the file that I had saved, the CAD document I was working on for the collection mechanism, I couldn't access for weeks because my computer was being worked on. So I had to quickly design another collection mechanism on an online CAD design platform instead of the platform that I was using. So I had to actually learn how to use two different CAD platforms and to quickly redesign what I did before. So also I learned about how valuable it is to save your data, which I did have it saved. I have it now, but it didn't help at the time when I needed it to be printed and get right so we can test the mechanism. So valuable skills of knowing if you have issues, if you're able, what you could do to fix that issue along the way.
Yeah, and I definitely learned a lot more about working with microcontrollers and different types of sensors. I had some experience in the previous years working with microcontrollers, but this is my first time working with a Teensy, specifically the Teensy 3.5. The one, I guess the greatest deal of like time consumption is actually getting the sensors set up and working. There's a lot of like kind of not nitpicky stuff, but like small stuff that could throw off the data or even like not make your sensor work if you don't have it set up properly. So it takes a lot of time to just go through and make sure you have everything in order. And it's definitely one thing that I take away from this is take the proper amount of time to actually learn what the sensors need to work properly. And yeah, it was a fun experiment to get coding all this stuff. So
And from the Hamline Hyper Pathfinder team, we want to thank the Minnesota Space Grants for presenting us this opportunity to test our engineering and electrical skills. And we hope future Hamline students can also participate in this wonderful program. Thank you so much and have a good day.
thank you.
Thank
Thanks.
you.
thank you very much.